Welcome to the Stormsurf Video Surf Forecast of the week starting Sunday, April 14th. Looking at significant wave heights for the North Pacific Ocean, we see remnants of a gale still producing 19-foot seas in the western Gulf of Alaska aimed east, but other than that, a pretty calm pattern. Let's get into the details. As usual, we'll start our tour looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When they do form, help direct their track. We're looking for a dip in the jet, sort of like there and sort of like there. And that would help set up sort of an eddy in the jet stream in the upper levels of the atmosphere, a counterclockwise flow, and that's the hallmark of low pressure. It also manifests itself down at the surface. That, of course, generates wind. Winds generate seas. Seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, turns into surf. All right, so we have two little troughs, but generally the jet is not very strong, maybe 130 knot winds pushing off Japan, and then you can't see it, but it really is splitting here before even getting to the dateline. Southern branch going into mainland Mexico, northern branch meandering through the Gulf of Alaska, trying to do something. There's also a bit of a split peeling off here before the jet even gets over the open Pacific. So there's just not a whole lot of energy to deal with, to help support anything. And we're in the change of seasons here, so the temperature gradients between cold air up north and warm air down south is not as strong, and it's really those big differences that fuel storm development, help push moisture up into the atmosphere, and everything's just kind of a generic mess right now. Nothing really driving the flow. All right, let's put the jet into motion. So we see a little bit of a trough as we get into Monday here on the dateline. Another little trough setting up just off the Pacific Northwest as we get into Monday night. That ought to bring some weather into California, but no swell production. Same thing pretty much with this trough here. Moving into the western Gulf, just there's not a whole lot of wind energy here. What is that, 120 knot winds feeding into it. And again, split jet stream, when you have that, you typically get high pressure in between, clockwise flow. That means north winds down the California coast and strong trades into Hawaii. So it's pretty much the typical spring pattern. Here we go again, something that almost looks like a trough, but notice that the jet's peeling off here. Probably no energy associated with this trough either as we get into Thursday and Friday. And here we are, we're almost a week out and just not a whole lot going on. A bit of energy, yeah, it's what, 110 knot winds. Consolidated, making it to the dateline, the jet splits, and everything just kind of weak and lackadaisical. And here we go. Notice the jet's also splitting again inland to Asia, coming down through the northern Gulf. Just a very weak pattern and not very, 1, 2, 3, like a triple split thing going on here. Just nothing really indicative of support for for storm development in the upper atmosphere. Let's go take a look down at the surface. Here we are, surface level pressure, surface level winds. Remember the jet split right there? There's the high pressure system, 1028 millibar high, not real strong, bit off the California coast. You can see it feeding trades, 15, 20 knots over the Hawaiian Islands, but a little bit of a lighter pattern here along the California coast. Low pressure, weak low pressure, like 1,000 millibar in the Gulf of Alaska. Let's see what happens here as we get into Monday. There we go, that little low pressure we talked about, maybe making some precip in California. It organizes. Also another low. I think there was a bit of a trough right in here, trying to develop on the north dateline region. 35 knot winds for 12 hours, and that fades out. And then another low over the Kuril Islands, very weak, unfocused, not doing anything. 30 knot winds as we're into Tuesday night. Just you get the kind of general idea. Okay, a little gale tries to develop. Was that Wednesday? Instantly gets pushed north. No fetch aimed at the U.S. 40 knot winds, maybe 45 for a second before it moves into North Canada. And we'll just sort of blast through this. I'm looking for anything that has 40 knot winds. Not seeing it. All I see is high pressure and weakness in the atmosphere. Again, still nothing. Here we are, Sunday, we're a week out, and nada. So, can't expect too much from the wave model charts, but let's go take a look anyway. But we're going to start off going back in time. This is Wednesday, 18Z Wednesday last week. Because there was a little gale, it developed, you see it there, 36-foot seas, pushing up to about 38-foot seas. That swell, I believe, is hitting now in California. What was the pure swell? Northern California, like 5 feet at 15 seconds, maybe 7-foot surf, but there's a bunch of wind swell mixed in, just really junky. Another system developed on Friday, very tiny system, 36-foot seas, very small footprint. That pushed over the date line and faded out today. In fact, the remnant seas that we saw on the significant wave chart are from that system. That swell will arrive in the middle of the week, something like that. But again, the wind swell issue will probably mask most of it, at least relative to North and Central California. Not a whole lot of energy aimed at Hawaii either. So not a lot going on there. And then here we are at, oh no, this is actually back another week. Okay, so that was current right there. All right, let's go move forward. All right, so the wave model chart going forward into Sunday night and Monday, little area of, what's that, 22-foot seas. We probably won't, maybe Hawaii will see a little tiny bit of energy from that. Not a whole lot for the U.S. West Coast, and that's gone. And then nothing. There's that other little gale in the Gulf. Here it is Wednesday, and we're like, another 22-foot seas or something quickly pushing up into Canada. And then after that, it just gets really quiet. North Pacific appears to be shutting down for the season. On good years with a good El Nino, you could still get solid storms into May, or at least, solid gales. Doesn't look like that's going to be the case this year. An early shutdown of the North Pacific looks imminent. So then we can hope for the southern hemi. Hope is the operative word here. We're just looking at the wave models, doing this really quick and dirty, see if there's anything. So there's some hints there have been on the models of something going on midweek here. Maybe a small area, 30-foot seas as we get into Thursday night, lifting northeast, but then fading. This is actually weaker than what it was last run of the model, and weaker than what it was yesterday. I think by the time we get into Thursday or Friday, nothing of real interest is going to happen. Now, that said, the pattern has sort of been like this. We're into Sunday already. Yeah, 32, 34-foot seas, but all aimed right off to the east. Here we are 180 hours out. There's been this consistent pattern. Actually, Southern California has been getting small, steady swell from these sort of, sideband swell. And the expectation is that'll continue, at the best spots in Southern California that magnify the swell. But in terms of most places north of Point Conception, probably won't be noticeable and will probably be buried in wind swell. So no real hope yet there. So let's go diving for wind swell. We're looking for wind patterns along the California coast and relative to Hawaii. See, high pressure, 1028 millibar high, generating clockwise flow as of 18Z Sunday, pushing trades at 15 to 20 knots over the Hawaiian Islands, making for some small wind swell east-facing shores. Actually, north winds have backed off relative to California. Not so much wind swell, a little bit junky conditions. But if you can get somewhere protected, there is actually some northwest swell wrapping in. I think, the spots. We're not going to name spots. Anyway, as we get into Monday night, low pressure moving in towards the California coast. Again, that would probably create some wind swell, and then high pressure is expected to surge a bit. Oh, we thought it was after that passes through. Here we are Tuesday morning. That's actually backed off from this morning's run of the models. North winds, not so strong. Trades backing off in Hawaii, too, is sort of this complex low pressure pattern tries to build in the Gulf and not doing anything. Maybe we'll actually get some swell from this system. Hard to say. We'll just go back and look. Okay, so here we are, right there, Wednesday morning, 40-knot winds, mainly aimed at the Pacific Northwest. Yeah, maybe some sideband swells we get in Friday or Saturday, with luck. So we're not really seeing a whole lot of trades finally start coming up a little bit in Thursday in Hawaii, but nothing obvious in terms of swell production until you see a 1032 millibar high starting to fill the Gulf of Alaska on Friday. Trades start kicking up Hawaii. You can see north winds starting to build along the California coast, and as you get into Saturday morning, we have 25 to almost 30 knot winds along the north and central California coast. and trades continuing relative into Hawaii, and then 35 knots over Cape Mendocino Saturday night. So that's good for wind swell production, but also with rather sloppy conditions for most of California. 15, 20 knot trades into Hawaii, kind of the same drill it's been. Sunday continues 30 knot winds, but this is interesting, right near the California coast. Maybe not so strong. Wind swell spots might actually be semi-rideable on Sunday. So that's kind of 20 knot trades continuing into Hawaii into next weekend. So we'll see. A little bit of hope. I mean, it's not completely over, but mainly we're looking at wind swell now and no real solid longer period swells expected to be generated. Taking a quick look at precipitation relative to California. Here comes the little low pushing up to the California coast on Monday morning. Rain for the north part of California, pushing down into San Francisco and Monterey Bay by Monday afternoon. Maybe a little bit of snow for the higher elevations of the Sierra, pushing the whole way down the Sierra overnight. Tuesday, with rain already starting to fade out along the central California coast, maybe making it to Point Conception. Snow showers continue into Tuesday morning, and then that fades out. High pressure building in, and you'll see all the precipitation just getting shunted off to the north around this high, which is, of course, rotating clockwise. We'll just roll this right on out. When was that? Saturday, maybe some rain backdoor front for the Sierra on Sunday. Even maybe some snow Sunday morning. Maybe. Hard to believe. Don't believe it. And here we are 180 hours out. So high pressure really setting up. That's the core sign of spring taking over when you see high pressure in the Gulf of Alaska and north wind pattern down the California coast. Also of note, water temperatures. We saw one reading at 49 degrees off of Point Reyes this morning. Point Reyes buoy there. A little bit warmer off from Monterey, like 55 degrees. But that's all a sign of north winds, strong upwelling, usual for this time of year. Here's a snow forecast for Squaw Valley, but it's pretty representative of the whole Tahoe area. We're looking at 6 inches of snow, all of it occurring around Monday night into Tuesday morning time frame, and that's about it for the whole 10-day window. Now here's the interesting part. There's your precip, that yellow line right there, right? Okay, this is the bottom of Squaw Valley. This is the peak of Granite Chief Peak and up by Palisades, about 8,900 feet. Where you see red is above freezing temperatures. So temperatures drop down on the 15th. That would be Tuesday morning in sync. It's Monday night, Tuesday morning in sync with the precip. And then temperatures are above freezing starting, late to, Wednesday. And from then on till they dip down below barely freezing not even freezing temperatures, but close to it, sleet temperatures, 34.6 degrees down to the valley and a couple of hours on right before sunrise on Sunday. Then temperatures start rising again. So we're starting to move into true springtime skiing conditions, corn, snow, that sort of thing. But we really need a longer duration of above freezing temperatures the whole way to the summit. But down lower elevations, Squaw, could be some fun corn snow as we get into the weekend and next week. And then Mammoth, even less snowfall, maybe about 3 or 4 inches, something like that, further down the Sierra. And the same sort of profile, but because they are higher up to 11,000 feet, you see the above freezing temperatures don't quite make it to the summit, but pretty much the whole lower half of the mountain, not to see anything below 32 degrees, starting, Sunday, Monday, let's say Tuesday night and beyond. So, springtime conditions setting up. All right, let's go take a look long-term. What's going on with the Madden Julian oscillation and, of course, El Nino. As usual, we like to look at winds on the equator, specifically in the West Pacific. So this is the East Pacific here. This is the West Pacific. There's the equator. 180 degrees, that's the date line. That's New Guinea right there. This data from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino, but they also have wind sensors on them. So this is not winds right at the moment. It's 5-day average winds. But you see winds out of the east the whole way across the Pacific, maybe a little bit weaker south of the equator in the far west Pacific, and it's the Kelvin wave generation area. This area from 135 west to about 135 east to 170 west, 5 degrees north and south of the equator. Draw a box right around there, and that, if you have westerly winds or westerly anomalies in that box, can help create a Kelvin wave. Those westerly winds, of course, have to blow for a week or 2 or 3. But so we're very interested, and if you have multiple Kelvin waves over time, that can help develop El Nino. So that's why, and even if you don't have Kelvin wave development, westerly anomalies driven by the active phase of the MJO also help feed energy into the jet stream, both in the north and southern hemisphere, and that in turn can help feed storm development. So watching the winds on the equator in the West Pacific in what we call the Kelvin wave generation area is key, especially during the active phase of the MJO. All right, so anomalies. How are these winds compared to what they normally are for this time of year? You just look at the arrows. Well, a little bit stronger out of the east in the East Pacific, pretty much dead neutral. Nothing really going on here in the Central Pacific, and normal in the West Pacific. So no active phase of the MJO. You want to see westerly anomalies here. We're not seeing that. Yeah, a little bit, but just no wholesale sign of, one, the active phase of the MJO. Winds capable of generating Kelvin waves, nothing like that. So pretty much a neutral pattern appears to be occurring. So let's just see what's been going on the past 7 days. 0 degrees, that's the equator. South America right there. New Guinea right there. 180 degrees, that's the date line. So Kelvin wave generation area, about in this area. The blues are easterly anomalies, the yellows are westerly anomalies, and it's got to be within 5 degrees north and south of the equator. That's where all the action is. And right now, this was as of the 8th of January. Looks pretty neutral, if not more easterly than westerly. Same thing. See, yeah, there's a whole bunch of westerly anomalies here, but they're associated with the storm. They're not on the equator. So you just sort of go day by day by day and pick down here. We're seeing nothing in the past 5 days that indicates westerly anomalies of any magnitude. And then here's the forecast chart with also past history. Again, so this is the whole planet on one chart. 180 degrees. That's the date line. So the Kelvin wave generation area would be basically between these two tick marks, and you just sort of go up and you see, okay, reds and oranges are westerly anomalies. So we had sort of like a long-running westerly wind burst almost the whole month of March. Yeah, it helped create some surf. There was some, some semi-legit waves at times during that period. But then as we get into about April 9th, that all fell apart, and that's last time we saw any real surf was last weekend up in Northern California. Solid swell, small mavericks kind of thing. Nothing really off the charts by any means. Here's where we are today. You see, so the easterly mixture of eastern and westerly anomalies, sort of like a dead MJO pattern indicated. And the forecast, the good news is it's actually improved, suggesting weak westerly anomalies building to a little bit stronger than weak, maybe a week out. Maybe that'll help feed the jet stream, but given the seasonal pattern and everything, there's no clear signs of any major storm development occurring in the North Pacific for the next week based on MJO and westerly wind patterns. So let's go out 2 weeks looking at outgoing long-wave radiation charts. Okay, another manifestation of the MJO. If you have, so this is basically it's sunlight reflectivity on the ocean surface. If you have negative anomalies, blues, that means more cloud cover, low pressure, the active phase of the MJO. Oranges and yellows, more sunlight reflectivity, positive anomalies, meaning high pressure, meaning the inactive phase of the MJO. And this, per the statistic model, just sort of looking down through, it looks like a weak active phase of the MJO building 2 weeks out in the West Pacific. There's New Guinea, right? Okay. While the active phase builds in the Indian Ocean. Let's go look at the dynamic model. It basically says the same thing, some sort of very weak flavor of the inactive phase of the MJO the next 2 weeks, while the active phase remains holed up in the West Pacific. So no real suggestion here, even for the next 2 weeks, of decent support for storm development. Phase diagram charts, another way of tracking the strength of the MJO, the active phase, and its relative position. So assume you're looking, the circle here, you're looking down on the North Pole, and you're watching the MJO move around the equator from the Indian Ocean, over the Maritime Continent, over the West Pacific, under the United States, across the Atlantic, over North Africa, and back to the Indian Ocean. The MJO moves, both active and inactive phase move against the flow, sort of like with the jet stream, if anything, from west to east. Where the heavy dot is, right there, that's where the active phase is. And if it's inside the circle, it's considered to be extremely weak. This is the forecast track. So, yeah, maybe a weak active phase over the next 2 weeks, trying to build in the eastern Indian Ocean, according to this, the statistic models, dynamic model. Just saying the inactive phase, or the active phase, noodling around, extremely weak. So, no different than what we saw anywhere else. Very, very, very weak MJO forecast. 40-day upper level model, another manifestation of areas favorable for precipitation are green, yellow not favorable for precipitation. So we'll say the active phase somewhere in the West Pacific, inactive phase in the East Pacific, but very weak. Active phase supposedly pushing, supposedly, but the other model is saying no, it's an inactive phase. So, you know, basically just this mixed neutral pattern with no clear, though you can sort of see precipitation, like this phase here working its way across the Pacific, and this phase here of precipitation working its way across the Pacific, but not even really associated with the MJO. CFS model going out a month. Here we go. So this was the February time frame. Strong Kelvin wave there. That actually, I mean, a strong westerly wind burst. The reds and oranges, westerly wind burst. But you get the general flavor the whole month of January and February. But now as we're into March, westerly anomalies getting weaker. And here we are today with just kind of this mixed blues easterly anomalies, or yellows, oranges, westerly anomaly. And kind of staying that way until we get into later in April. And then you see blues, that would be the and the dotted contour here. That's for sure the inactive phase, the MJO moving from the far West Pacific to the date line. Then that fading out. Very kind of mixed, incoherent, not strong pattern at all forecast. And then the 3-month CFS model. Okay, this is past history here. And this is, again, Kelvin wave generation area roughly down in between these two tick marks, going up in time starting in December. Here's that big westerly wind burst in February. That has created a Kelvin wave that is traversing underneath the equator towards Ecuador. And then the pattern sort of fell apart. Here's today. Here's the forecast looking forward. The good news here is continued weak westerly wind anomalies holding in the Kelvin wave generation area. We'll overlay the MJO. Here is, right now we're in the active phase of the MJO, and it's all but dead. And then we go into this time period from, we'll say April 20th out till about somewhere in early May. Just no MJO signal. Some of the models say inactive MJO. Either way, weak westerly anomalies forecast. That's not. So then supposedly we have this active phase, the MJO, but that's so weak with one contour there, it's not even really. None of this is just this dead neutral pattern for like the next 3 months at least, but with weak westerly anomalies in the Kelvin wave generation area. Overlay the low pass filter. And so this is these solid contours. Areas favorable for sort of a low pressure bias, if you will, right on the date line. That's kind of a good thing, especially in the winter months. And that's supposed to hold at least into July, but then you almost get the sense that this, so we had 3 contours here. That's all but gone now. 2 contours, so we get in July, and even that might be fading down to 1 contour, but at least we don't have this. See that dotted thing? That's, if that were over the date line, that would be La Nina. But no, it's over. It's been in the Indian Ocean, and it's supposed to die and just sort of go neutral. So I'd say we're kind of moving into a very, if we were weak El Nino last winter, even weaker El Nino next winter, you know, in the October, November, December time frame, and fading from there. So basically dead neutral. All right, what's going on in the ocean? Subsurface temperatures. So this is the East Pacific here. This is the West Pacific here. Date lines right there. This is just on the equator. And this is, again, data from the TAO buoy array. But what you can see is sort of get a sense of what the temperature profile is. Warm water at depth down 150 meters in the east. This is 28 degrees centigrade. And then, I'm sorry, in the west, right? And in the East Pacific, warm water, but much shallower. And if we were in La Nina, this would be far more shallower. So we're actually doing pretty well here. 29 degrees, making it to about 172 west over the date line. 28-degree isotherm last week, I think, was about 143, and most of the winter had been toggling between 150 and 160. It's made a major eastward push to almost, was this 125 west. We think that is associated with an eastward moving Kelvin wave from the big westerly wind burst that occurred in February. It takes 3 months for a Kelvin wave to move. Basically, you'll take this warm water here and start pushing it off to the east, and that's what it's doing, and you can see that here. In fact, it's a little more pronounced, but not great here in the anomaly. Differences from normal for this time of year. You see generally 1 degree or greater degrees centigrade over the entire equatorial Pacific. Normally, if you had La Nina, you'd see -1 to 2 degree anomalies here. This negative anomaly at depth stuff may be a little bit concerning long term, but we're not too worried about it quite yet. In fact, we have 2 degree anomalies. Here is the Kelvin wave. Now, it doesn't look like much on this chart. We're going to show you another chart, far more pronounced. In fact, let's just go do that right now. Here you go. So this spells it out a lot more. So there's different modeling software used. This is probably the more optimistic, and the other chart was the more pessimistic. So what do we got? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 4 to 5 degree anomalies right here. So this is all this is warmer than normal temperature. The date line's here. So we're all the way over to New Guinea. A steady flow of warm water pushing east, going to gurgle up, and that's the last little bit of the upwelling phase of the Kelvin wave cycle. In between Kelvin waves, and this is the 3rd Kelvin wave, you get a little pocket of cool water. It sort of gurgles up, and it's been doing that along the coast of Peru and off Ecuador for the past 2 or 3 weeks, maybe 4 weeks. That's all but about gone now. This guy, we think, is going to impact the coast. Water temperatures will rise significantly along Peru, Ecuador, Colombia, that area. They get caught by the trades and then start pushing off to the west, driven by the trades. But the real issue is another Kelvin wave coming behind this, and we sort of think not. We think that most of the warm water, this was up to 30 plus degrees a year ago, and we think most of that's kind of tapped out now. I mean, it was never really an El Nino. It was never really expected to be an El Nino, and it never really became an El Nino. But we've had this long, steady, warmer than normal surface water pattern that's building, and this is expected to continue. This is probably right here. That's at least 3 months worth of warm water, so 3 to 4 months. So let's say, where are we? April, May, June, July, somewhere in August or so before all this gets tapped out, and then we're not sure what's going to happen after that. So not a bad situation for now, into the fall even. JSON-2 satellite data. Okay, so here is South America, Central America. There's New Guinea there. That's the date line. That's the equator. You see these yellows, which are like 0 to 5 centimeters above normal. Couple of pockets of 5 centimeter anomalies. So all this means is, so this is strip out all the waves, strip out wind waves, strip out the tide. What this means, there's a bump on the ocean surface on the equator and surrounding areas, just meaning that it suggests there's warm water at depth, and warm water, because it expands, creates a bump on the ocean surface. But we're seeing a lot more of these pockets of neutral anomalies showing up, meaning whatever Kelvin wave this is kind of losing some of its energy, maybe not as strong as it was. Let's take a look at another chart here. Upper ocean heat anomalies. So this is the West Pacific here, East Pacific here. This is going back in time. And the oranges, reds, whatever, those are above normal surface temperatures. The blues, slightly below normal surface temperatures. So you see a Kelvin wave last year in the May time frame. That was Kelvin wave number 1. You can see the warm water pushing across and hitting Ecuador. in the June-July time frame. You get this little pocket of upwelling cooler waters. Kelvin wave number 2, much bigger. It looked pretty impressive. September into the December time frame. And then here's our current upwelling phase of the Kelvin wave cycle that's all but gone. And here's Kelvin wave number 3, again, created by westerly wind bursts, active phase, the MJO in the Kelvin wave generation area. Where's that? 135 west right there to about 135 east to 170 west. So in that box there going the whole, so you get the west winds blowing here or westerly anomalies. That takes warm water, pushes it east, impacts the Ecuadorian coast, creates warm water in the East Pacific. And if you get enough of these and they're strong enough, then you get El Nino. So here's Kelvin wave number 3, strongest of the batch. Still hasn't made it to the Ecuadorian coast yet, hanging. You know, you see they all kind of fade a little bit, but they eventually make it to the coast. We expect this one will too. It's just got another couple of weeks to a month to go before it actually hits. And so with that, let's go take a look what's going on the surface, not subsurface, on the surface. Surface water temperatures, high res, you can see the resolution here. Pretty good resolution, satellite-based sea surface temperatures, updated daily. Okay, here's the equator. There's Ecuador right there, Peru right here, Colombia right there. And you see generally warmer than normal waters over from 20 degrees south, 20 degrees north, the whole way across the Pacific. There's the date line. You can see this whole region from pretty much south. There's Hawaii, so a bit southwest of Hawaii, filling the Pacific the whole way. And these Kelvin waves, they've been coming, hitting here, gurgling warm water to the surface, and then the trades, steadily easterly trades here, take that warm water and push it back to the west. But there's no clear, like, burning El Nino picture here. You'd want to see a lot more concentration of, like, see those dark, heavy reds cooking in this area here. We don't see that. In fact, so upwelling phase of the Kelvin wave cycle, see that blues, cooler water? They were much more pronounced in this area last week and the week before that. They're slowly fading out. We think there's going to be warming in here somewhere in the next 2 months, month to 2 months. And that'll hang on into the middle of summer or so, then slowly fade as it pushes off to the east, driven by trades. Here's the trend for the past 7 days. Yeah, we got warming in pockets along here. It was actually pretty cold here when the upwelling phase of the Kelvin wave cycle was going on. That's starting to moderate now. There's weak warming in pockets here, but no big signs of like some massive warm-up building. Just kind of, yeah, it's neutral to gently getting warmer over mainly the central Pacific as of this week. And then here is the overall pattern. Yes, in the main, so Nino 1.2 is this area sort of right in here along Peru, Central America, that sort of thing. And it's warm there, a little bit of warming right there. And then the main El Nino monitoring region, 120 west to 170 west, 5 degrees north and south of the equator. Yeah, it's warmer there, 3/4 of a degree it looks like or something. And generally, when you have this sort of triangle-shaped thing going like that and it's all warmer than normal, that's a sign of El Nino. And we're sort of seeing it, but just not a very strong signal at all. Just, gentle warming at best. Here's the temperature trend for the past 4 months in the Nino 1.2 region, that area right around the Galapagos, Central America. If anything, you draw a line through this, it's going down. Today's temperature, 1 degree below normal, 1.091. But we think both of these spikes here and this is all attributable to the upwelling phase of the Kelvin wave cycle. We think that'll start warming up in another 2 weeks or so. Then the main El Nino monitoring region, Nino 3.4, now you see a different trend here. It was hovering around 0.5 degree until we got into March. It sort of stepped up. Today's value, 0.821 of a degree above normal, so 3/4 of a degree above normal or so. And pretty stable. I mean, officially that's El Nino. Anything more than 0.5 degree above normal for 5 months, basically, which that's kind of where we're at, or very close to it. But just the minimalist of minimal El Ninos. During the last big El Nino, we had temperatures that were up above, like 2 degrees above normal, 1 3/4 to 2 degrees. Then you get a major atmospheric response from that. You get a very minimal atmospheric response from 1/2 degree or a little bit more than that. And even if you get those temperatures, it takes, another 3 months after you get them before the response happens in the atmosphere. So, okay, we got our 3/4 of a degree rise in temperatures starting in March. 3 months after that, you're into June, and it does nothing for the North Pacific. Maybe it'll feed the southern hemi jet stream a little bit. We'll see. Still a little bit early to know, but we'll, at some point here in the near future, we're going to start transitioning to just monitoring primarily the southern hemi, and we'll see whether these temperatures have any effect there. So speaking of which, let's see if the warm temperatures are having any effect on the atmosphere. 2 indices we use. First one, Southern Oscillation Index. Difference in pressure between Darwin, Australia, and Tahiti. When the index, the daily index right here, is positive, that suggests La Nina, or the inactive phase of the MJO. When it's negative, that means lower pressure in Tahiti than over Darwin. Then that means maybe El Nino, or at least the active phase of the MJO. Today, 1, 2, 3, 4, 5 days of negative anomalies, followed by what was 7 days of positive anomalies, followed by something like 57 days of negative anomalies. So it almost looked like we're getting into El Nino here in April, and it's all just kind of falling apart now. It's kind of just normal. Anyway, 30-day average strips all the noise out of that, just sort of gives you a sense of where you're at. You see we're down at minus almost 7 at one point back in early April. Today, minus 2.11. That's basically dead neutral. And then the 90-day average strips even more of the noise out. We're at minus 6.13 because at one point we were definitely looking like El Nino was trying to get going. And it's still suggesting that. But we expect this is going to start rising as well. Here's the 30-day SOI average on a chart, okay? You can see, where are we? January 2017, it was kind of positive, weak La Nina. Then we got into spring of last year, and we started -5, -10. You can see this is the active phase of the MJO, inactive. Active phase, stronger than the inactive phase. Active phase. And we had a kind of a strong inactive phase. And we had a strong active phase. But you see, the trend was sort of downward. We suspect that's going to start working its way up. Anyway, so you just sort of get graphically the idea of what's happening in our tendency towards if there were an El Nino building. If it was, we'd want to be down and holding steady around 10 to 15, minus 10 to 15. We're nowhere close to that. And then there's the ESPI index. Instead of the difference of pressure, it's the difference in precipitation north of Darwin and over the Pacific. When it's dry here and wet here, and why would it be wet here? Because ocean temperatures are warmer than normal, because there were Kelvin waves, because there were westerly wind bursts over here. The whole drill. That's why we so much watched the Kelvin wave generation area and the MJO and westerly anomalies and all that stuff, because that's what helps feed all this. Anyway, so when you have more warm water here, you get more precipitation here. So this index, today's index, the SPI index, which is the measure amount of precipitation here relative to here, is 0.83. So yeah, a bit more precipitation here, and this is pretty much the highest. It's steadily the highest it's been here all season, suggesting yes, there is warming here. You're getting more evaporation, you're getting more precipitation, but nothing over the top, just a general tendency towards a weak El Nino. And then finally, the projections for Nino 3.4 sea surface temperatures. So where are we? Today we're, right around in here. Temperatures per this, say we're 0.95 above normal. We're actually about 0.8 or something like that. Close enough. You get the general idea. And here we go. Kelvin wave number 3, supposed to erupt, pushing temperatures to 1.2, maybe 1.25 degrees above normal in the, June time frame. And then no more. This is when we say we don't think there's any more Kelvin waves coming, because this model just suggests a steady decline through the summer. Fall in October, we're 0.6 of a degree above normal. When we get to December, we're 1/4 of a degree above normal and holding. I mean, that would suggest maybe slight enhancement for next fall and winter. But I would think for the summer, if El Nino is going to do anything, might goose up our chances for southern hemi swell into California, Hawaii for the summer. It tends to what it really does is build high pressure over New Zealand, which in turn allows storms. They go track under New Zealand. They ride up the east side of the New Zealand high. You get a lot of energy pushing north towards Hawaii and the U.S. West Coast in the year after a solid El Nino. This was not a solid El Nino, but maybe we'll get, average to a little bit above average, a 6 on a 1 to 10 scale this summer. Then as we get into next winter, probably even less, just average, maybe a little bit more. Hard to say. Actually the rainfall this winter was more than it was expected. The surf was less than expected, so relative to California. So, it's hard to tell, especially when these weak El Ninos, weak La Niñas. Well, the weak La Niñas are more predictable than the weak El Ninos for sure. But anyway, you get the general idea. So, a little bit of hope maybe for the summer, and a little bit of hope for the fall, but then a weaker late winter pattern probably. So to wrap things up, one more swell left relative for California from the North Pacific. Nothing really happening yet in the southern hemi, but there's some sense that the southern hemi might be more productive than normal. Long term, no El Nino really for next winter, just a little bit warmer than normal pattern, kind of an average year. Nothing obvious, no La Nina, no real El Nino, just kind of right down the middle. So that's certainly better than La Nina. We'll take it. Anyway, that's it for this week. We may not do it next week. We'll see how things go, see how our time management goes. But anyway, that's it for this week. Do it again, if nothing else, 2 weeks from now. Thanks for watching.